Welcome to the intro lesson on acids and bases. So, we're going to define acids and bases, and then we're going to go through some basic sort of introduction in identifying acids and bases. So acids were first defined as substances that dissolve in water and release H+. And then bases were defined as substances that when they're dissolved in water, they release OH-. That is not the definition that we were going to use in AP chemistry or now. Later, in 1923, so almost 40 years or more than 40 years later, Bronsted and Lowery defined acids as anything that accept protons or accept H+ ions. So anything that release, any acids is anything that release H+ ions, or release protons, and then bases as anything that accept or take in protons. And we're going to see these definitions applied throughout this lesson. So the question now is, what is really, so what is a proton? So H+ results when you put an acid in water and it dissociates into H+ and its anion, which in this case is chlorine. Now why this happens is that chlorine is a very electronegative, so it hogs most of the electrons. Right? Remember, electronegativity is how much an atom wants to gain electrons. And since chlorine is a very electronegative, it really has most of the electron. And when this goes into water, it actually steals all of the electrons and allows the H+ to lose its electron and dissociate into water as H+. So essentially, H+ is a proton without an electron. It's a hydrogen atom which has given its one electron to the anion. And it's essentially a proton. But what generally happens in water is that remember, you're putting this in water, is instead of it floating around just as H+ in solution, it actually like hangs onto a water molecule. So H2O gains an H+, and it becomes H3O+, which is called hydronium. So writing the dissociation of an acid either this way with water, where this is losing the chlorine and the H is hopping onto the water to become hydronium, or writing this way if they ask you to write the dissociation of an acid. Either are correct, and you use these interchangeably when we're showing the dissociation of an acid either way. So the first goal of this lesson, is going to be to identify acids and bases in a reaction. So if we take a look at this, HF is becoming F-. So that means it's releasing H+. So it's the proton donor and the acid. Okay? Whereas water here is accepting H+ and becoming hydronium. Okay, so since it's accepting H+ or accepting a proton, it's the base. Okay, now here's an important, now this reaction is in equilibrium, so that means it's reversible, and that's where the Ka and Kb's are going to come in a second. But every acid, what it becomes when it releases H+, has a conjugate base. And every base, when it gains H+, has a conjugate acid. Because if you wrote the reaction in this direction, this guy would be acting like an acid because it would be becoming water, and this guy would be acting like a base because it would be accepting H+. So every acid has a conjugate base, and that's what it becomes after it releases its H+, and every base has a conjugate acid, which is what it becomes after it gains H+. And we're going to practice with that now. So if you take a look at this one, this is an acid because here, if you see it lost H+ and became OH, so this is its conjugate base. And this is acting like a base because it gains H+, and this is its conjugate acid. Now, sometimes a substance can act as both an acid and a base depending upon what it's with. And this is called Aceophoterism. So you can see that water in this case, right, it's losing an H+, so it's acting like an acid in this case. But in this reaction, it's acting as a base because it's gaining H+. So a substance that can act as either an acid or a base, depending upon which it's with, is called amphiphotéric. Okay, so sometimes, depending upon what it's with here, when it's reacting with ammonia, water's acting like an acid, and here when it's reacting with hydrogen fluoride, it's acting like a base. So it can behave. So substances can behave both like an acid and a base, depending upon what it's with. So we're now going to practice identifying conjugate acid and conjugate base pairs. And there was actually a question on the AP exam that was like this. So we're going to practice that now. So what I would like you to do is pause the video and try to identify the acid and base in the reactants and then its conjugate acid or base. So if we look here, this guy right here is losing an H+. So it's acting like an acid. And then this is its conjugate base pair. And then this is gaining H+, so this is acting like a base, and this is its conjugate acid pair, and we can abbreviate conjugate acid Ca and Cd. So in this one, what did Cn become? Well, Cn gained H+, so this is acting like a base, and this is its conjugate acid, and this one lost an H, right? So it's acting like an acid, and this is its conjugate base. And then for our last and final one, well, this guy, he gained an H, or it gained an H+. So it's like acting like a base, and this is its conjugate acid. And then this lost an H+, so this is an acid, and this is its conjugate base. So we're going to summarize conjugate acids and conjugate bases, and then I'm going to upload this video and finish the rest of the lesson in another video. So if you have an acid and they ask you to get the conjugate base, so the acid will have one less H, and the total charge will decrease by -1 because it's losing H+. It's losing H+, so it's becoming negative. Where the opposite to is if you're finding a base's conjugate acid, remember the base is gaining H, so it will have one more H, and it's gaining an H+. So then its total charge would increase by 1. So for the questions, it says, what would be the conjugate base of H2PO4-1? So that means that this is acting like an acid, right? This thing is acting like an acid. So when we ask for its conjugate base, we want to know what it's going to become, okay, after it acts like an acid. So it's going to lose an H, right? It's going to lose an H. And since it lost something positive, it's going to become even one more negative. So it's going to be -2. And then lastly, we want to know the conjugate acid of this guy. So that means this guy is going to act like a base. So its conjugate acid would be H3PO4. And its total charge would increase by 1, so since it has overall negative charge, it would have no charge. So again, this is sort of the summary. It's much easier to identify conjugate acid pairs in a reaction, and that's usually what they do on the AP exam.